Hey guys, welcome to Elevated Systems. I'm your host CJ, and today I have two newcomers to the AIO market. Now, while both of these companies are very well known in the PC market, especially as case manufacturers, they've each recently released their first all-in-one liquid coolers, and I purchased the 240mm versions of each of their offerings. From InWin, I have the SR24 liquid cooler, and brand new from Lian Li, I have the Galahad AIO 240. So the plan is to unbox each cooler and take a look at the pieces and parts, then quickly go over installation of each AIO, and finally I'll run some thermal benchmarks for each one to see if there's any significant performance difference between the two. Now guys, this video is going to be pretty in-depth, and while I encourage you to watch it all, I've included chapter markers below so you can go right to the content that you want to see most. Well, that's it. Let's get these unboxed, starting with the InWin SR24. Okay, this is a fan and this should be the accessory box. Let's see what we have in here. Now, doing my research, this cooler is compatible with almost all modern consumer sockets, including AMD Threadripper TR4 or TRX4 or the Intel HEDT 2066 socket. And it certainly feels from this box that there's enough hardware for that to be true. So it definitely looks like we have all the hardware we need to mount this AIO to whatever we need to. And InWin was even nice enough to individually bag and label each set. But it looks like there's no user's manual, but there is a QR code. Now we have two 120mm InWin Jupiter fans, the AJF120s to be specific. These fans have a rated RPM range of 500 to 2500 RPM, resulting in max airflow of 101.5 cubic feet per minute and a static pressure of 4.22 millimeters water gauge. The transparent fan blades are illuminated by 6 hub-mounted addressable LEDs. Now, onto the AIO itself. And the first thing to notice is this huge 100mm high pump block. This block is massive, and I guess it has to be because it contains two independent pump motors in separate chambers. Basically, there's one chamber on each side of the block, each with an independent motor. One side pulls liquid from the radiator and down into the cold plate, and the second side pulls the liquid from the cold plate block and through the radiator. It's their twin turbines, and if one fails, the second one still keeps the liquid moving, albeit there will be a drop in pressure. The high density aluminum radiator measures in at 277 by 120 by 27 millimeters with 14 rows of liquid tubes and a fin density of 17 fins per linear inch, and is connected to the pump block by standard 400mm rubber hoses sleeved in braided nylon, and they seem pretty flexible. Okay, let's open up the Lian Li Galahad. And as you can see, this is the white version. Let's start with the hardware again. This bag of stuff isn't as separated as the previous AIO, and while this cooler is compatible with pretty much all the mainstream and HEDT Intel sockets, it only has mounting hardware for the AMD AM4 socket, so no Threadripper support. And here we have two Lian Li static pressure 4-pin PWM fans. These fluid dynamic bearing fans have a rated RPM range of 800 to 1900 RPM, resulting in a maximum airflow of 69.17 cubic feet per minute and a static pressure of 2.6 millimeters water gauge. The 9 translucent blades are illuminated by 12 hub-mounted addressable LEDs, and I have to say, these are some of the most solid feeling and hefty fans I've felt for a while. That leaves the AIO main body. The pump block is 74 millimeters in diameter and almost 62 millimeters high, and features a sealed triple chamber design, allowing for more efficient unidirectional flow between the pump chamber, connecting chamber, and cold plate chamber, prevented heated liquid from backflowing. The pump motor runs at a maximum speed of 3,300 RPM. The high density aluminum radiator measures in at 273 by 123 by 27 millimeters with 14 rows of liquid tubes and a fin density of 18.5 fins per linear inch, and is connected to the pump block by a standard 400 millimeter rubber hose sleeved in braided nylon. But I don't know, the pump seems to be mounted in a weird way. It almost seems, I don't know, backwards. But I guess we'll see how it works when we install it. And that does bring us to installation, but first, let me show you what I'll be installing it on. For demonstration and testing, I'll be using an open air test bench, simply because no single case I have would be representative of every possible case out there, so the temperatures I get during benchmarking will be best case scenario. And for testing, I'm using a Ryzen 7 3700X on an Asus Prime X570 Pro motherboard. Everything else isn't really important to CPU temperature testing, and it's just there so I can boot into Windows and run the tests. I went with the 3700X, well, because it's the hottest chip I currently own, but it's very representative of a common CPU to pair with a $120 to $130 240 millimeter AIO. I'll also be test fitting each AIO in my Be Quiet Pure Base 500DX on a LGA 1151 socket in both the front and top radiator installation configurations for a comparison of ease of installation for each AIO. Finally, when I do the thermal testing, I'll also be comparing both of these AIOs to this $70 Cooler Master Master Liquid LC240E to see how these AIOs compare to the most basic and inexpensive 240 millimeter AIO on the market, coming in at about half their price. Also, as a testing note, I won't be using the thermal paste that comes with each of these coolers, because during the testing I'll be removing and remounting the blocks multiple times, and there just isn't enough included for multiple applications. So to keep the testing consistent, I'm using Noctua NT-H2 thermal paste for all applications. Okay, let's get started, and this time I'm going to start with the Lian Li Galahad, because the pump block uses the AMD AM4 mounting brackets that are already installed on my motherboard. Now, I'll be mounting the fans in a push configuration, pulling fresh air from below and pushing it up through the radiator. And the radiator is installed parallel to the motherboard, similar to installing it on the side panel of a case like the Lian Li PC011 Dynamic. And isn't that the case everyone has? Okay, the radiator's installed. Now, the pump block has the Intel bracket pre-installed, but we need to install this bracket for the AM4 socket. The mounting hardware consists of these two clips that grab onto the AM4 mounting brackets here, and two of these thumb screws. Now, I've already tested this so I don't look like a fool on camera. Well, at least not a bigger fool. And I think the easiest way to do this is to get the clips on the bracket and then the thumb screws just started on the clip. Our thermal paste. Don't forget to remove our little plastic film on the bottom. And now you can hold the clips in place to get them onto this bracket here. and then tighten them down. Trying to do this without the thumb screws on first requires more than 2 hands and a fair amount of cursing. Now, the pump connects to the motherboard AIO pump header directly with a 3-pin DC connector. And the fans connect directly to the CPU fan header using the included PWM fan splitter cable. The RGB cables on the pump and the fans can be connected in 2 ways, either directly to the motherboard 5-volt 3-pin ARGB header using these 2 cables, or by using the included SATA powered RGB controller, which is what I'm gonna do because I don't have any RGB control bloatware installed on my test bench. Now, our RGB connector coming from our RGB controller only has 2 RGB connectors on it, and this splitter allows us to connect up to 4 total RGB devices. Fan 1, fan 2, pump, and SATA power. Okay, let's fire it up and see if it worked. Fans are blowing, RGB is illuminating. Now, one of the neat features of the Galahad is that this top aluminum part rotates so you can properly orient the logo. Now, if you don't want to see the logo, you can add this included aluminum magnetic disc to the top of the block. Okay, we've fast forwarded in time and I'm gonna install the InWin SR24, and this AIO doesn't use the AM4 brackets, so let's get those removed. Okay, I got one of them removed, and now I'm going to install the included AMD standoffs, screwing the short side into the motherboard. Now the same thing on the other side. Now, this mounting method doesn't include the plastic spacers you typically see in AIO hardware, so after the standoffs are installed, the back plate will still be loose. Now, I've already installed the radiator in the same way as I did for the Lian Li AIO, so next we need to locate the AMD mounting brackets that look like this and slide them onto the block. And then we need to locate the 4 thumb screws. Okay, now our thermal paste again. And again, we want to ensure we remove our protective plastic film on the bottom of our cold plate. And then we're just gonna line up our standoffs and attach our thumb screws. Okay, the block is installed. As far as connecting everything, we have this cable, which has a 10-pin connector that plugs directly into the block here. And then the fans plug into the PWM connectors on this cable. It's important to note that this cable has 3 PWM connectors, presumably because it's the same one used with the 360mm model. So you need to ensure that one of your fans is plugged into the connector with the 4 pins. If you plug both fans into the 3-pin connectors, you won't have PWM control of your fans and they'll default to DC. So here is my 4-pin PWM connector, so I'll plug that into this fan, and then the other one can go to either of the PWM connectors that has 3 pins. It's just missing one of the pins. And then you have a standard PWM fan connector that will plug into your CPU fan header on the motherboard. Finally, there's a SATA power connector that you connect to SATA power. I think how this functions is the fans are essentially plugged directly in and controlled by the motherboard, and the pump and pump RGB is powered directly by the SATA connection, meaning we won't have any control of the pump speed or RGB on the block. In fact, I'm pretty sure the block just lights up white unless there's a problem with the pump, in which it'll flash blue to red, indicating that there's a problem. As far as the fan RGB, it can be connected directly to the 5-volt 3-pin ARGB motherboard header using this cable, or again, controlled by the included SATA powered RGB controller, which is how I'll be doing it. So keep in mind, doing it this way will require 2 extra SATA power connectors. Okay, starting it up. Fans are blowing. Pump is running. Okay. Let's roll into the thermal benchmarking and see how these AIOs stack up. A total of 9 benchmarks were run. Each benchmark was run 3 times, then the cooler block was uninstalled and remounted. This was done 3 times for a total of 9 runs of each test. The thermal results were charted using the Ryzen Master utility, and the recorded maximum and average thermal results are in degrees Celsius, and an average of the 9 runs minus the ambient room temperature at the time of the test, which ranged from 23 to 25 degrees Celsius while testing. Each test was run for 10 minutes using stock or default CPU frequencies and the Asus motherboard PWM standard fan curve unless otherwise noted. The first test was the Prime 95 using the small FFT preset. Temperatures were very consistent during the test, and final averages only varied by 2 degrees. The next test was a software X265 encoding of a 4K X264 video file using Handbrake. The transcode took approximately 11 minutes to complete. The InWin SR24 was again able to maintain temps 1 degree lower. Moving on to the Cinebench R20 test at all stock settings, the InWin cooler was able to maintain temps 2 degrees cooler. The most CPU punishing test, which saw the highest temperatures at stock settings, was the AIDA64 Extreme Stress Test, again seeing the InWin cooler 1.5 degrees cooler on average. For a gaming benchmark, I looped the Red Dead Redemption benchmarks twice, which simulated 10 minutes of CPU demanding gaming. Temperatures expectantly varied the most during this test, but all coolers maintained an average of 27 degrees above ambient. Our final test at stock settings was the Blender Classroom Render, again seeing the InWin cooler 2 degrees better. This is also where the Cooler Master AIO unfortunately ends, as I broke the mounting clip while remounting it, so I wasn't able to get results for the final 3 runs on the last few tests. Now for this Cinebench R20 test, I overclocked the Ryzen 7 3700X to 4.4 megahertz at 1.4 volts, while still using the stock fan curve, and thermal results narrowed, seeing max temps equal and only a single degree difference in average temps. For this Cinebench R20 run, the CPU was at stock frequency, but the AIO fans were set to their max RPM, and here we saw the Lian Li cooler close to within a half a degree on average. For the fan normalized test, the stock AIO fans were replaced with a set of Noctua NF-P12s set at 1700 RPM, and interestingly, for the first time we see the Lian Li Galahad do a better job cooling our CPU, maintaining average temperatures 1.5 degrees lower. Another interesting point, though I didn't include the results of the Cooler Master AIO as I wasn't able to do the third run of benchmarks for this test, but the average results of the first two runs I was able to do were identical to the InWin SR24. Okay, let's talk about what we saw in those graphs. Basically, the InWin cooler performed better overall, keeping the CPU up to 3 degrees cooler, but the Lian Li cooler cut the margin as the thermal load increased and finally surpassed the InWin cooler in the fan normalized test. Why? Well, first we need to talk about how cooling works in an AIO. Now, if you really hate physics, I guess this is one of those little chapters down there you can skip, but it'll be informative. An AIO removes heat from a system at 2 points: the cold plate and the radiator. Both points remove heat a little differently, but use the same basic scientific principle of forced convection. The heat from the CPU is transferred to the copper cold plate. Liquid is then run over the microfins on the back of that cold plate, transferring the heat to the liquid. The liquid is then run through an aluminum radiator, transferring the heat to the aluminum. The fans blow air past that aluminum fins, transferring the heat to the environment. Now, each of these different materials, water, copper, aluminum, even the air, has a different heat transfer coefficient or thermal conductivity. Measured in watts per meter Kelvin, I'm not going into the math, but basically the thermal conductivity of air kind of sucks at about 0.03, while the copper is great at around 400. Aluminum comes in at about 250, but is much cheaper than copper, hence aluminum radiators. And water is about 0.6, which, yeah, seems low, but that's still about 20 times better than air. So these individual thermal conductivity numbers are not entirely important. How they relate to each other is. I'll get to that in a second. Back to forced convection. As you might know, convection is simply the movement of heat from one location to another by the movement of fluids. So take this heatsink. In its current form, the heat from the CPU is transferred to the heat fins and from the heat fins to the air. As the air is heated by the fins, it rises and is replaced by cool air. That's where the movement of fluid comes in, and yes, air is considered a fluid here. Air heats, rises, cool air moves in, infinite loop. Add a fan to force air past the fins. Now you have forced convection. The only way to improve the cooling of this forced convection system is to A, increase the surface area of your heatsink, B, increase the flow rate of your fluid, or C, if possible, you can reduce the temperature of your fluid. So back to the AIO and the 2 points of forced convection. First being at the cold plate, but to be honest, there's very little an AIO manufacturer can do to improve the heat transfer, given that, for one, the surface area is limited to the socket area. And even if you increase the surface area of the microfins, more smaller fins, you're eventually limited by the heat transfer coefficient of your liquid. Remember that 0.6 watts per meter Kelvin number? Water can only absorb so much heat as it flows over the copper. Most of the tweaks and improvements AIO manufacturers make to their pump block assemblies involves way to keep the hot liquid away from the motor, because the motor is actually cooled by the same liquid that cools the CPU, and the cooler the motor, the more efficiently it works, and the less heat it can transfer to the block. Just know, hot block, bad. The second point of transfer is at the radiator, where the liquid transfers heat to the aluminum, and then the aluminum transfers heat to the air as it's forced past by the fans. Now, here's where manufacturers have a little more room for thermal improvement. They can increase the surface area of the aluminum by increasing the fin density or even the thickness of the fin stack, and they can increase the fluid rate by forcing more air through the radiator. To a point. See, the heat transfer coefficient is actually a curve. So you do get to a point where you can't see any measurable results. You can even get to a point where the airflow gets so extreme that it results in measurable friction and the curve starts to fall. But that's not really a concern with a PC fan. So with that knowledge now in your brain, let's see how those principles were applied to these two AIOs. First, the InWin Jupiter fans are significantly more powerful, having a max speed that's 600 FPS higher than the Lian Li fans, resulting in 47% more airflow and a 62% increase in static pressure. Now, the Lian Li radiator is denser with about 8% more surface area based on the fin density, probably more considering as I'm sitting here in this shot, I can see that the fin stack on the Lian Li radiator is actually thicker than the InWin. So what we see at lower thermal load is that the InWin fans are blowing harder because the standard fan curve applied by the motherboard increases the fan speeds as a percentage of maximum RPM. So at 50%, the InWin fan is spinning at 1250 RPM, while the Lian Li fan is spinning at 950 RPM. So we have a greater volume of air with the InWin cooler, improving the thermal transfer. Now, as the thermal load increases and the fans of both AIOs ramp up, the InWin radiator starts to reach the top of that thermal transfer curve I described, but the Lian Li cooler still has some heat transfer headroom because of its increased surface area of the radiator. That's why we see the Lian Li AIO do much better in the fan normalized test. But no doubt out of the box at default fan curves, the InWin cooler kept our CPU cooler. But that performance came at a price, and that price was noise. The InWin AIO was significantly louder than the Lian Li at every load level. Now, I don't have a working noise level meter to measure decibel levels, but I do have ears, and so do you. So let's roll this B-roll footage and you can judge it for yourself. So we talked about cooling, noise. Now let's talk about installation. Now on the test bench, the InWin cooler was much easier to install. It lined right up and I had no problem. The Lian Li, however, was a bit more tricky. It did take some trial and error off camera before I figured out to start the thumb screws on the clips first. It was also a little difficult to rotate the block into position because of the weird way the tubes connect. This seemed a bit weird to me because this is basically the orientation many people would install this Lian Li cooler into the best-selling PC case of the past 18 months, the Lian Li PC011 Dynamic. But the InWin cooler, no problem if you're installing in that case. Now, installation to an actual standard case, the Be Quiet Pure Base 500DX for this example, was, well, the opposite. Despite the weird backwards tubes on the Lian Li AIO, it was pretty effortless to install in both the front mount and top mount positions. And while the rotatable logo is a nice feature, I didn't even need to rotate it, it just went in right. The InWin cooler, however, was much more challenging, and that was mainly due to the tubes terminating at either side of the large pump block. Because of that, rotating the block to be able to get the logo right side up really wasn't possible. The only way to do it was position the radiator with the tubes at the top, which is never a good idea if you can avoid it because of the possibility of pump failure due to liquid permeation. Basically, as liquid permeates out of the system over time, air builds up and rises to the highest point. If the highest point is this chamber, it can eventually get full of air and the pump can't pull in any liquid. No liquid, the pump overheats and, well, dies. So finally, what are my overall conclusions about these two newcomers to the AIO market? Well, first, as far as the InWin SR24, I think most of their R&D and manufacturing budget went into the twin turbines pump block here. Having dual independent redundant motors is a nice option. So if you have a system like my main rig that has a lot of uptime, pretty much 24/7, and you were hesitant about going AIO because of the possibility of failure, then this is a solid option. Also, if you just want the best cooling out of the box and don't really care about the noise, then the InWin pulls ahead there. But also keep in mind, for gaming, they were essentially equal. One downside I do see with this AIO is the compatibility with small form factor cases. I'm specifically thinking about the new Cooler Master NR200 or even the Dancase M1. I know they have supported cooler heights over 100 millimeters, but when you consider you have to add the thickness of the radiator and fans and say in the side mounted configuration, that might not work. As far as the Lian Li Galahad, well, first, it's simply a premium looking and feeling AIO at the $120 price point. The brushed aluminum on the shroud and the aluminum bezel are very nice. It's also one of the quietest AIOs I've ever worked with. The fans are quieter than the Noctua NFP12 Redux fans I used for the fan normalized test, and those are the quietest fans I own. Now, this level of quietness does sacrifice some heat transfer, but I think that's the balance Lian Li was going for, and considering the very small gains the InWin had over it, I think they struck a pretty good balance. The only criticism I really have is with the AMD mounting system. While I love my cheap Cooler Master AIO as my test bench cooler exactly for the easy clip-on mounting system before I broke it, the Lian Li solution didn't make it much easier. In fact, I'd say a standoff and bracket system with the 4 thumb screws on the corners like the InWin AIO used would be a simpler installation. I did have a problem with the black sleeve cables coming from the white pump block when I first took it out of the box, but after installing it and running them over a black motherboard, it made sense. And that's it. I'm not going to recommend one of these coolers over the other. That'll take much more long-term testing, but let me know in the comments which AIO you like better and why. I will be using one of these coolers in my personal gaming build. Which one do you think it'll be? If you want to hit, check out my last video, which will be coming up at the end screen right after I remind you to do all of this stuff to support future content. I hope to see you in the next one. Until then, stay safe.